Hey, so today we're going to go over how to take an existing ERC20 contract and convert it to be a Superchain ERC20 contract. So first of all, what is the Superchain ERC20 standard? A token is considered to be a Superchain ERC20 when it follows these four criteria. First of all, it needs to be a valid ERC20. Then it needs to implement the ERC7802 interface, which I'll go into in a little bit, but essentially at a high level, it has the cross-chain mint and cross-chain burn functions on your contract. And then it's going to add permissioning to be able to allow the Superchain ERC20 bridge, which is a contract deployed at the same pre-deploy address on all OP stack chains, and gives that specific contract ability to call cross-chain mint and cross-chain burn on your token. Then we need that contract to be deployed at the same address on every chain in the Superchain. I'm going to jump into it. I'm going to talk first about what the ERC7802 interface is. If you look here, it's pretty simple. There's only two new functions and two new events. And it adds a cross-chain mint, cross-chain burn, and then two corresponding events. But first of all, to look at ERC165, just to recap, it's just a way for a contract to be able to declare that, hey, my contract has support for these following interfaces. So ERC7802 also expects to all token contracts to be ERC165 compatible. But kind of into the fun, the meat of it. So if you take a look at these kind of functions, I want to just go through a high level when you're bridging from one chain to another, what's really going on. So say you have a user that's trying to bridge from chain A to chain B for some token 1. First, the user calls Superchain ERC20 bridge, which is deployed at the same address on all chains, all OP stack chains, and then calls send ERC20 for that token. Then the Superchain ERC20 bridge calls in to the token's cross-chain burn function. So what's going on here is that, hey, I want to bridge 20 tokens from chain A to chain B, and the bridge is now going to burn 20 tokens from that user's account on chain A. Then at some point in the future, like a user or relayer is now able to call Superchain ERC20 bridge.relay ERC20 on the destination chain. And what happens then is that the Superchain ERC20 bridge now calls that token on chain B's cross-chain mint, effectively kind of giving you back the tokens that were burned on chain A. So high level, you have the Superchain token bridge burning tokens on chain A and then minting the same amount of tokens on chain B. So you can kind of see why this interface is necessary to give the Superchain ERC20 bridge ability to be able to do these functionalities. So say we have a token contract that looks kind of like this. Very basic OpenZeppelin ERC20 contract. It implements ERC20 and ownable, and it's a pretty common pattern where you just have a specific owner and only that owner is allowed to mint new supply. Now, what does it look like once we added all the necessary functionality to turn it into a Superchain ERC20? Okay, so this is the new contract, my Superchain ERC20. And essentially at a high level, you see that now it implements the ERC7802 interface, adds the necessary functions, cross-chain mint, cross-chain burn, supports interface, that's the ERC165, and emits a few new events. But overall, not that much code diff here. So let's take a look at what is going on here. So to recap supports interface, this is just telling the world that, hey, my contract supports ERC7802, ERC20, and ERC165. Pretty straightforward. And then to kind of into the meat of it, if you look at cross-chain mint, what's going on here? So in cross-chain mint, you can see that first of all, it immediately reverts if it's anyone other than the Superchain ERC20 bridge that is calling into this function. Obviously, if you don't have this check, then anyone can call in to be able to mint new supply, and we don't want that. So we're adding this check in the beginning. Then it mints using the internal function that's given by ERC20 implementation for OpenZeppelin, and then emits a cross-chain event. Small caveat about what this msg.sender here is. So this is your token contract, right? So who is going to be calling this contract? The Superchain ERC20 bridge, right? And everything else is just going to revert. So MSG.sender is always going to be the Superchain token bridge here. And similarly, in the cross-chain burn, what you have is you first check that make sure that only the Superchain ERC20 bridge can call it, and then calls the internal function from OpenZeppelin, and then emits the corresponding event. So, like one question that's pretty common here is like, hey, like I already have an owner. Is it okay if for more than just the Superchain ERC20 bridge to be able to mint? Say I want to also be able to mint new supply. Yes, that's perfectly possible. The Superchain ERC20 bridge does not have to be the exclusive caller to be able to mint. In fact, you could have something like, hey, the MSG.sender needs to be owner, or it needs to be the Superchain ERC20 bridge. That is fine. Like, as long as Superchain ERC bridge has permissions to call these two functions, then that token should be usable. So high level, this is it. We've converted an existing ERC20 token into a Superchain ERC20 token. What was required is you take the correct interface, ERC7802, and implement all the functions that are required. Just making sure that in cross-chain mint and cross-chain burn, you have proper access controls to make sure that only the Superchain ERC20 bridge and the people who are allowed to mint your tokens are able to get past and call _mint. And then just to make sure that it emits the correct events once that is successful. So that's it.